Perhaps you are a student currently studying computer engineering courses, or maybe you are someone who's contemplating diving into the world of programming. As you're stepping into this programming journey, you will likely come across various tutorials available on the internet, ranging from simple Hello World programs to advanced projects. But have you ever wondered what is the difference between the starter projects that I can create on my computer and the sophisticated software produced by big tech companies? Today in this video, you'll get a glimpse into the software development practice in enterprise. I will talk about the following topics: development environment versus production environment, overview of the SDLC, software development lifecycle, and an introduction to different team roles, application deployment, and CI/CD. So let's dive in. As a software engineer, I installed the programming language on my computer, set up my IDE, created a folder, and wrote some code that could execute. I felt accomplished and proudly told my colleagues that I have done my work. But no, it was too early. Obviously, I couldn't just hand over my laptop to my customer and say, hey, go to this folder at this location and run that Python script. You will like it. Here, there's an important term, deploy, or you can call it deliver. I remember back when I just started my internship, I frequently heard some terms like deploy to staging, deploy to production environment. It took me some time to grasp their meanings. Now let's assume that we are coding for a typical web application. Let's say the web version of ChatGPT. For publicly accessible environments, with a domain name available on the internet, we call it the production environment. For example, for ChatGPT, the production environment is chat.openai.com. And besides production, there may be other environments that are not directly accessible by public users. There may be one or more internal environments such as dev, test, staging environments, depending on the needs of each company and team. Software engineers need to deploy their code to these non-production internal environments for feature demonstrations, functional testing, or performance testing, etc. So inside the organization of the OpenAI, there may be different instances of environments on different domains like dev.chat.openai.com or staging.chat.openai.com. Writing code is just one phase of the software development lifecycle. Before coding begins, there's a process involving product managers gathering requirements from the users. And then a solution architect will review these requirements, proposes design solutions, and estimates the resources and difficulties of this implementation. Then the coding tasks are defined and assigned to different software engineers. Since multiple engineers usually collaborate on the same project, SCM, source code management tool, is usually used to view and manage their code. Well-known SCM tools include Git, Subversion, and Mercurial. After this, the code is deployed to the staging environment for testing before delivery to the client. During testing, bugs may be identified on the staging environment after the feature deployment. In such cases, software engineers need to understand the bug, find the root cause, modify the code to fix the bug, and redeploy the latest code to the staging environment. Once all tests pass and the day of delivery comes, the feature is finally deployed to the production environment for public user access. We just discussed a full process from requirement definition to feature delivery within the software development lifecycle. The SDLC is usually completed by a team, include different roles, which may include a product manager, whose responsibility is to communicate with clients or stakeholders, gather and define product requirements, ensure software development aligns with users' expectations and business goals. A solution architect who analyzes requirements, propose system design solutions, ensure the robustness and the scalability of system architecture. A project manager who manage the overall project process, resource allocation, and communication to ensure the projects are completed on time, within budget, and to the desired quality. Some designers who design the user interface and user experience ensure software meets user expectations and usability standards during the usage. Software engineers who design, code, and test softwares based on the requirements ensure delivered code meets quality standards and project requirements. Quality assurance engineers who conduct functional performance security testing ensure software stability and reliability in various stages and environments. DevOps engineer who manage software deployment, configuration, and maintenance ensure system high availability and continuous integration or delivery. The allocations of these roles and responsibilities may vary depending on specific needs of the organization and the project. In agile software development, team members typically collaborate in a more corporate and cross-functional manner. A large feature is usually broken down into many smaller features and tasks. These are delivered to the client in a shorter cycle, typically within 2 to 3 weeks as a sprint, using a more rapid and incremental approach. Hence, this entire SDLC changes from a long marathon to a series of short sprints, resembling a relay race. In order to speed up the delivery and increase the efficiency, automation, the entire process becomes a key from our local development environment to internal staging environment and eventually to the production. Here, DevOps help team deliver software faster by designing, implementing, and maintaining the CI/CD pipelines to facilitate the automation. Continuous integration CI involves automatically merging code changes into a shared repository. Automated tests are then run to validate these changes. CI ensures that code changes are regularly integrated into the project, reducing the integration issues and providing early feedback to developers. Continuous deployment CD take a step further after the CI automation by automatically deploying these code changes to various environments such as staging or production. So CD pipelines automate deployment tasks such as provisioning infrastructure, configuring environments, and deploying applications. So in case you have no idea of what I'm talking about, here's a screenshot of a sample Jenkins pipeline. It consists of different stages and each stage completes a specific task. So this kind of automation pipeline ensures the efficiency and consistency of a deployment. That's all for today. If you like this video, please subscribe to my channel. I will see you in the next video.